Welcome everyone to the second session of the Swedish-Canadian Knowledge Exchange, focusing on advancing healthcare with AI. And today we have a focus on AI in action for administration and operations. And my name is Ebba Josefsson Lindqvist. I have with me Peter Kursvelli and a few other AI Sweden colleagues. I'm just going to mention one of them, and it's Anders, who will help out a little bit with the technology today in the meeting. So if you have any questions or issues, please use the chat function, but then we'll save the discussion part for later. And to mention what the focus will be of today, besides the headline, we will today explore how AI can transform administrative workflows and hospital operations through practical and actionable methodologies. We'll also hear about effective project management strategies of AI implementation, emphasizing iterative design, clear milestones, and measurable outcomes. And we're very happy to have two very good speakers for this. I will introduce them very shortly. And then we'll go into the discussion and have an open discussion for about 40 minutes or so. We are trying to share a few things in the chat about the project. So the project's website, if you're interested in reading more about the project. And we're also trying to share some materials for today and today's speakers' resumes. So keep an eye on the chat, please, for that. We'll be recording the first bit, so the presentation part of this session. And then after the presentations are done, we're going to stop the recording and go into the Q&A part and the discussions. And for this, we really want to have an open climate and open discussion. So that's why we're turning off the recording for that. But with no further ado, I would like to introduce our speakers of today. And we're very happy to be able to welcome Neil Kaw, Senior Data Scientist at Unity Health Toronto, together with Manson Locke, Vice President, People and Culture at Unity Health Toronto. So good morning, Toronto. Let's see if we can also share your screen while I'll stop sharing my screen and just make sure everything works fine and smooth.
Are you able to see my screen, Ebba?
Yes, perfect. Looks great.
Okay. Good afternoon, everyone, and thank you for the introductions. I'll dive right in. So to set the context, first of all, I wanted to talk a little bit about the group that I'm a part of. So I work in a department called Data Science and Advanced Analytics, or DSAA, at Unity Health Toronto. And we essentially function like an internal consulting group where administrative leaders or clinical leaders from throughout the hospital can bring to us a data science idea that they have, and we'll bring it to fruition. So the department is subdivided into 4 teams. Quickly, I'll go over them from the upper left and go clockwise. So the advanced analytics team is the team I'm part of. These are data scientists whose skill set is really in developing and deploying models using AI methods like statistics, machine learning, optimization. Next is the data integration and governance team. These are the data engineers, ETL developers, system administrators. They develop and maintain the infrastructure that we depend on, including the data systems. And they also develop the data pipelines that actually provide the data which models can make use of. Next is the product development team. These are software engineers and user experience designers. They design the actual tool that will face the users. In our case, these are usually web applications, and these applications embed the models and the data which provide the functionality. And fourth is the product management team. This group supports product delivery from end to end, everything to do with initiating projects, managing projects throughout the life cycle, supporting implementation, and covering evaluation after the fact as well. And also everything to do with maintaining engagement with end users. So what I'm going to talk about first actually has mostly to do with that 4th quadrant of product management. I'm going to talk a little bit about project management methodologies in general before getting into specifics and specific examples. So I want to jump down to the second bullet. And in the world of software engineering, I want to contrast two main approaches to project management, which are waterfall, the traditional one, and agile, which has become more dominant in the last 20 years or so. The idea of waterfall is that it treated the life cycle as a project as a sequence of processes which would be completed one after another in order. So the idea was that first of all, the project team would first elicit the full set of user requirements, meaning a complete description of the functionality and the features that the software end product has to have. Then the team would use those requirements to design an architecture, select the components, and so on. After that, the engineers would actually start programming and code up the entire product. Then there would be testing, followed by delivery to the customer. Contrast that with Agile, which has become more dominant in the past 20 years. The idea of Agile is that things do not occur strictly in that sequential order. Rather, it's all about delivering incremental and iterative functionality to the user in short bursts. Usually every 2 weeks is the idea. So the project team works in these 2-week sprints, and within each sprint cycle, the activities of requirements gathering and design and implementation all happen concurrently, so that after 2 weeks, the project team can deliver some new functionality and features to the user and receive rapid feedback. For this to work, the end user actually has to be embedded in the project team. And the idea of this is that it allows rapid responsiveness to changing requirements from the end user. It's also very useful in situations where requirements are not necessarily fully clear at the very beginning of the project. So data science has really adopted that methodology, I would say, from software engineering. Data science and AI essentially is just a specialized form of software where at the center of the software, there happens to be a special type of object, which is a model or an algorithm. But very similarly to waterfall and agile, data science has had a number of approaches that span that spectrum. The classic approach from more than 20 years ago was called CRISP-DM, which stands for the Cross-Industry Standard Process for Data Mining. This was a waterfall approach to data science where the team was expected to go through a sequence of activities one after another. Business understanding, data preparation, modeling, model evaluation, and then deployment. More recently, people have proposed agile versions of that. So just to name one of the more prominent ones, Microsoft proposed a process called the Team Data Science Process, or TDSP, which is essentially just an agile adaptation of the CRISP-DM process model. In our group at DSAA, we use elements of both planned and agile. So on the next slide, I'll just give you an overview of the project lifecycle that we've adapted. And in general, I know that every organization essentially ends up coming up with their own project management methodology. So an overview of ours, the waterfall aspect to this are the 3 light purple rectangles: initiation, build, followed by post-launch. These are 3 big phases which we do expect to occur sequentially, one after another. But within each of those phases, we try to be very agile. So I'll explain a little bit more one by one. The initiation phase is where the end user actually brings their idea to the project team. The project team will have conversations to try to translate the problem into a somewhat more formal specification, do a little bit of data extraction and data analysis to try to understand what might be possible. Once we have a bit more of a well-defined problem and we're committing to the project, we enter the build phase. That's where most of the substantive data science work actually happens. Everything to do from model building to user interface development to database development to deploying it, and also creating instrumentation so that we can monitor the performance of the models and tools over time. All of that happens in that middle build phase, which tends to be the longest one with the most activity. And within that phase, we try to structure ourselves in agile 2-week sprints, where every 2 weeks, we try to do a bit of analysis and development, show what we've come up with to the end user, use their feedback to rapidly iterate and revise the requirements and the design. The third phase is post-launch. That's where we engage in activities like evaluating how well the implementation went and what impact the tool has had. And of course, maintenance is also required. To circle back to the waterfall aspect of this, the one waterfall aspect we have is that we do want those 3 phases to happen in sequence. So to help that happen, we have these gates that exist in between those phases. So the first gate is, so these are the 4 red digits which were on the diagram previously. The first gate is that we just need the idea to be reasonably thought out before we actually start doing any data analysis. The second gate is that after we've completed initiation, the team has to make a decision about whether we are actually committing to the project. And in that case, we formalize the resources and commit the resources to work on this. In order to move past the build phase, we need, obviously, the product actually has to be built. But beyond that, it also has to have had quality assurance and testing and documentation. In other words, we need to be in a position where we can actually support this in deployment, rather than simply having a software product deployed and online. If we satisfy ourselves that that criteria has been met, then we launch and we move into the post-launch period. And the number 4 is not exactly a gate in the sense that we're not moving on to another phase, but it more simply marks the boundary of where the bulk of the project activity has been concluded. We just have to ask ourselves the question, has this product been supported for long-term maintenance? And if so, then we can move it into a somewhat lower activity state. The other aspect of project management methodologies is that generally they always specify deliverables and artifacts, usually along with a set of templates that the project team can use as they move through the life cycle. So we've adapted a version of that for ourselves as well. We have 13 core artifacts, which are listed in the bullets on this slide. So from left to right, as we go through the life cycle, these bullets list the core artifacts which at a minimum the project team is expected to start and complete before passing through the numbered gates. I won't read out what all of these artifacts refer to, but just skimming over them, you can see some of these are fairly clear, like a project charter, a plan for how to evaluate impact, documentation of the model, documentation of the deployment architecture, and so on. What I will do is dive a little bit into the intake form specifically, because I think that could be informative. So the intake form is the very first documentation deliverable, which is expected from the project team. The context for this is the form in which we expect the end user to bring their data science idea to the project team. So we ask the end user to fill out a series of questions, and we go back and forth with them to figure out and refine the answers to these. So this includes, for example, who will work closely with us on the project team? What is the problem? What's the magnitude of the problem? What are the existing workflows, either clinical or administrative, that relate to this problem? And how does the end user envision that an AI tool could help refine or augment those workflows? One critical question is also, what is the target impact measure? And we need to know this because we need to know after deployment, how will we know whether this engagement was a success or not? And then there's also a few questions about risks, community and collaboration. And at the very bottom is another very important question, which is, what are the parameters for sunsetting this proposed AI tool? Because we cannot maintain an infinitely growing set of AI tools in deployment over the long term. We need to establish in advance what are the conditions that we would consider to actually sunset a tool and take it offline and decide that it has just served its useful life. So I want to turn it over to Manson now to talk about some specific project examples.
Okay, thanks very much, Neil. So this will be a little bit of a switching of gears. What we wanted to do was talk about some actual AI deployments at Unity Health, and we decided we would focus on health human resources deployments. And the reason for that is because we sit on a massive amount of data for our more than 12,000 employees, and we've been working on different forms of deployment to support improving administrative processes related to health human resources since about 2017. So we've got a number of different projects we can speak to. and I will talk to 3. I will note I'm not a data scientist, so for some of you, this may be noticeably short on technical details, but I'm sure Neil will be happy to take all of your questions about those technical aspects of these deployments. But what I hope to do is to be able to get you into the minds of some of the end users that were involved in and brought through this project methodology that Neil's talked to, and be able to share with you some of the problems and solutions that are meaningful to these end users, and from their perspectives contribute to good deployments. And also give you a bit of an end user's perspective of what they felt were some of the key success factors in this project lifestyle that they really attributed to some of the success. So this first initiative is something that was put into play for our interdisciplinary resource teams at Unity Health. And just briefly, an interdisciplinary resource team functions like an internal agency to the organization. They have a number of clinical staff on their team, and their role is essentially to deploy those staff around the organization to cover short-term unplanned absences. I wanted to get into the manager's headspace around why this was so important, and spent some time talking with him about that time when they were contemplating this deployment. He described for me a period of real tension and stress for him as a leader of these IRTs. His role essentially was to make sure that the organization had safe staffing at all times, while at the same time having to meet the pressures of ensuring he wasn't overstaffing and exceeding his budget. He described for me a process that was massively time intensive, involved a large number of stakeholders from finance, his leadership team, a steering committee. Because of these resources, it was done far too infrequently. And he said, despite all the work, the predictions wound up being poor, never gave him the absolute comfort he was making the right decision. So what happened in terms of coming together with DSA and the deployment, they landed on a dual model solution where they combined a demand forecasting model to predict the staffing needs for the organization with a staffing optimization model that could predict the staffing needs that would be required, which enabled him then to be able to test different staffing models and know precisely what the outcomes of those things would be, to really refine the decision making that would go into what was needed to be able to properly staff. He described for me a situation where his stress was reduced, the administrative demand was reduced, accuracy went up, and in the end of the day, it meant safer staffing for the organization, reduced overtime and agency costs. I asked him, in this project lifestyle and this deployment and development process, what were some of the most key success factors from his perspective? One of the things he described was the accessibility of the data science and advanced analytics team. Neil shared with you the intake form, which means any team can access DSAA. But what he also described, and others described, is also the opportunity to simply pick up the phone. The data science and analytics team is not a team hidden away in the background. They are part of the organization, and they bring forward a different way of looking at solutions to administrative challenges. Next slide, please, Neil. Then the next initiative I'll share with you is a solution in our emergency departments. The emergency department struggled every single day with this problem of having to set assignments for nursing staff. They're broken up into multiple zones for acute care, charge, ambulance offload, triage. And the manager, when I was speaking to them, described to me the situation of having 2 or 3 hours having to be spent every single day to allocate these assignments for nurses. And despite all of the effort they put into it, it was a continual source of conflict for the staff. The nursing staff felt that the assignments were unfair. Inevitably, there wound up being gaming of the system, errors would occur, and there were concerns around the safety of the staffing. The solution that was brought forward was one where information related to staffing demand, what was required in those schedules in the different zones, could be brought together with workforce data, including information around the skills and abilities of the nursing staff, in order to automatically produce those assignments every single day. And asking her what this meant to the team, she said that these assignments went from 2 or 3 hours of work to create to 5 minutes. And more importantly to her, as a leader of this team, the nurses have clearly responded because the process is more transparent and fair from their perspectives. The rotations are fair. She spoke to having more confidence in the safety of the staffing because there's confidence that the nurses are qualified to fill the zones. And she described the fact that sometimes there's the opportunity now to be able to look at historical records to address historical complaints and concerns. I asked her what was the key success factor related to the project lifestyle and the development approach with the data science and analytics team. And she said it was the openness of the team to have involvement of the impacted staff right from the get-go. She actually pulled in one of her RNs, an educator, to actually participate and be one of the project leads. And she said because of that, they were able to find immediate improvements, which made adoption and change management much easier. And it's really contributed to sustainability. The last initiative that I'll speak to, Neil, if you switch, is a deployment we did around the prediction of nursing turnover. I know the situation in Canada may have been different than yours, but here the pandemic resulted in unplanned nurse vacancies that were massively heightened, created major risk to patient care. And this is a sustained challenge we had for multiple years. And we got together with the data science and analytics team, and we asked ourselves, with the data that we have available to us, is there any way for us to be able to identify these risks of nursing turnover and gaps before they happen, so that we can be on top of the problem before it actually occurs? And so we came together with them. We developed a tool that would aggregate nurse-specific data like age, sick time, overtime, et cetera, that would actually give us a risk prediction of turnover for individual nurses that we then were able to bring together in an aggregated clinical program dashboard that managers, directors, vice presidents, and the human resources team could see to identify where we needed to focus our efforts around retention and recruitment before the problems manifest. And what we heard from this team, and I was on this project team, around what was a key success factor was the time and effort put into a rigorous but also a flexible approach for testing that incorporated end users from all around the organization, HR, recruiters, clinical leaders, et cetera, and a real flexible approach to that was integrated with the nimble development approach. We'd learn, we would go back, we'd reiterate, we'd come back to the table. And I gave a great deal of sense of involvement from the teams to be able to contribute to sustainability. So in summary, just to highlight the kind of three main things that came out from end users of these deployments that contributed to their success and that were a part of the project lifecycle that Neil talked about, really is before you even get into the project, making sure that the data science and analytics team is accessible, that it's a service that's open, it's seen as another way to address operational problems. It's not something that's hidden behind the scenes with a lot of gatekeeping. There's the opportunity to have a discussion, and that's the way we find a lot of solutions that are meaningful. The next thing is to really focus on real problems that matter and that are solutions to day-to-day challenges. So project selection is vitally important. The involvement of the impacted individuals at the onset, and really focusing on things that make the daily work life of individuals easier, fosters better engagement, stronger change management, and then has contributed massively to the sustainability of solutions afterwards. And lastly, which Neil talked about a lot, is this co-development approach. Each of the teams that I spoke to, and my own team would say the same thing, there's this real spirit of experimentation that happens when we come together in this project life cycle. You get a really crystal clear idea of what you're trying to achieve, so rigorous problem definition. But once you have that shared vision of what you're trying to accomplish, there's lots of the room for experimentation, flexibility, and nimbleness to look at different ways of achieving it. And it's interesting to see that sometimes the solution at the end of the day that was the best was not at all what the team started with. So this is just a summary of some of the end users' perspectives of the project lifecycle and what they illuminated as most important that contributed to their success and a good experience working with the data science and analytics team. And I'll stop there. Thank you.
Okay, I just wanted to check if Neil had something to add to that, or if we can move on to the Q&A session.
No, nothing more for me. We can move on to Q&A, I think.
Okay, great. And with that, thank you so much. And